Thank you, everyone. Welcome to SQLSaturday-Bangladesh. This one is special for me because I was born and raised in Bangladesh, and I spent a lot of time in Dhaka. I met Ahsan in July, actually, this year in person. So thank you again for organizing, and those who are participating in Teams or live in Facebook. So let's go. So I'll be talking about checkpoint and a little bit about why checkpoint is important, why should we care, and I'll also have some few demos to show you how to monitor, how to control, if in case you suspect that you have an issue because of checkpoints. And if you have any questions, please put in the chat, and so the organizers can stop me and I can answer those questions. I will share the slide deck and the demo code through my GitHub repo. So you do not need to write this. If you want to download, feel free to download, use it, do whatever you need to. I'm not going to read the whole slide, but I really want you to take a note of what you see on the left side, my contact. So in case, if after the presentation, if you have any questions, comments that I did not cover, or you want to follow up, you can always reach out to me. I do monitor all four, so you can use anyone that you feel like. So the first thing is, why do we need checkpoint, right? Because if we cannot appreciate or we do not know, then this talk wouldn't make much sense to you, right? If we don't know why you're doing something or why do we need to learn something, that learning really doesn't make sense or doesn't stick to you for a long time. So let's talk about this for a minute. The checkpoint is primarily for recovery. And when I say recovery, is mostly during unexpected shutdown, not a planned shutdown. What will happen if our SQL server lose its power, lose its network, or whatever issues happen, or maybe there is a bug in the call stack, call stack overflow. For some reason, you see a dump got created and SQL Server got shut down or restarted. It needs to recover, because anytime we have a transaction that has been submitted to a SQL Server and the user, and when I say user, it can be an application, can be an end user or sitting in a terminal using SSMS, other tools, whatever it is. Once they get an acknowledgement that their transaction was completed successfully, then we need to guarantee that that piece of data persists. Doesn't matter what happens, right? If it's a sudden shutdown, power failure, or whatnot. How SQL Server maintains that? So it creates every checkpoint creates a known good point, and then when there is an issue, if there is a restart or a power down, SQL Server will start recovering from that point. SQL Server knows exactly from which point I should start recovery. And how do they recover? We'll talk about that later on. And that is the main purpose of checkpoint. Because if checkpoint doesn't happen frequently, then there will be a huge number of transaction logs that SQL Server has to sniff through and decide which one to remove and which one to apply. So before we go to the checkpoint, I want to briefly talk about something called ACID property. And especially out of the four principles of ACID properties, the last one is called durability. And the durability is directly related to our topic today about checkpoint. So ACID property, the term actually started in 1983. If you are interested about history and transactional databases, relational databases, then you probably heard that. Andres Reuter and Theo Harder, they actually coined the term ACID, and I'll briefly talk about it. And there are some difference of opinion. There are some people will say that no, this term actually existed since 1973 from IBM, and for history geeks, there is still some difference of opinion. So the first one is a atomicity. I'm not going to go detail into this because you can have a full talk just on these four principles. So I'm just going to briefly touch, which will make our talk relevant, especially the last one, as I said. So the atomicity means that each transaction is treated as a single unit. What do I mean by that? If you say that I withdraw money from account A and I deposit it into account B, we cannot have a situation that we just withdraw the account from account A, and then we had a power failure, and once the server is up, it sees that the money was withdrawn from account A, but was never deposited to account B. That's a bad thing, right? Depending on which side you are, whether you own the account A or account B. So if this is in a one transaction, that is a bank transfer, you have to guarantee that the money was withdrawn and deposited. And if something happened in between, we have to make sure we reverse the withdraw from account one, right? And put the money back into account one. So that's atomicity. The next one is the consistency. Consistency can be a confusing term in this context. And it came from, and do not confuse this with eventual consistency, because if you are using Cosmos DB in Microsoft, you will see there are different consistency level, and one is called eventual consistent, and this is not the same thing. Consistency is a bunch of rules that actually ensure the correctness of data. And to give you an example, like a foreign key, check constraints, primary keys, unique keys, these are in place to ensure the correctness of data, and that's what consistency is. And isolation is within a transaction. Sometime when you are doing your work, you need to hide your work so others cannot see till your work is completed, right? Because you do not want to show somebody your half-baked work. Like I said, if you are withdrawing money from account A and putting in account B, and somebody wants to know the balance of account A or B, you don't want them to see the balance in this transition time. You might want them to hold on in a queue till this transfer is done because it's already started, and then they should come and see your balance. And yes, I know there's exception with the uncommitted isolation level, and people should use that, not in generally, but use some caution when you're using. And the last one we'll be talking about is a durability. And again, it goes back to what I said at the beginning. Once a transaction has been completed and has been committed, the result in the database, we should guarantee that the data persists. Doesn't matter what malfunction happens, right? It's your storage failure, your power failure, doesn't matter what happens. We should guarantee that this data is there. And now, how do we do that? There are basic. Hold on. Can you still hear me, Asanbhai, or is there a problem?
Yes, we can
Yeah,
hear
we
you.
can hear.
Oh, okay. So somebody was just not in mute. Sorry. So I lost my thought for a minute. Yeah. So how do we do that, right? In case of a crash or a power failure, there are two main things that we'll be talking about. One is called write-ahead logging, and the other one is a recovery phase. And the recovery, there are two different things. One is called redo and undo and redo. This is where the checkpoint will play a major role during the recovery phase. There are a few other things that I want to talk about that we should understand before we go deep into the topic. One is called clean versus dirty page, and I'll also show you this during the demo. A clean page is when we read a page from the buffer and we haven't modified that page. Since we read from the buffer or since the last checkpoint, if we haven't modified that page, then we call this a clean page. But if we have modified a page that we read from buffer or since the last checkpoint, then we'll mark that as a dirty page. And as a data professional, we have access to monitor this, to go into our cache. And if you have a memory of 1 terabyte, be careful. If you're trying to find this out, it can take for a long time to get a result set. But just for your understanding, if you have a small database, you want to do some demo, which I'll show you. There's a DMV called DMOS buffer scripters. Over there, you can see if a page is a dirty page or a clean page, and you can actually go and track back that page where it belongs to, right? Which table, which index, and all that. So I mentioned write-ahead logging, 2 slides ago, right? So let's look at this. What do I mean by that? Because you write-ahead logging, because of write-ahead logging, SQL Server can run a lot faster. And what do I mean by that? If you are doing an update of 1,000 records, if you have to write each record back to the disk every time, SQL Server will be a lot slower, right? And SQL Server doesn't do that just because of this mechanism called write-ahead logging. So I'll walk you through. I know this slide can be a little bit overwhelming with so many boxes and so much data onto this, but I'll try to go step by step and explain this. And this is one of the important aspects that we data engineers, database operations, traditional DBAs, we should all understand. So once we begin a transaction, what happens? So, for example, we issue a command called update, this table A set column name equals something. So like get date. We try to update the date time stamp for all the records in a table. And hypothetically, say if this table has 1 billion record, what happened? SQL Server is going to fetch page that where the data reside into the memory. If it's already not in the memory, right? It first checks. If the page is already in the memory, then of course you don't have to fetch it. Then SQL Server does something. It puts a lock on the page, and SQL Server also do something called latch. And latch is a big topic. I'm just going to use a simple English. I'll just say it's a short-term lock, right? So for a very tiny period compared to a lock. So latch is protecting the physical structure of the data or of the page. So it's going to take a latch. It is going to generate a log record about the update. It will also put that log record number, which we call LSN, log sequence number, onto that page. So every page is tracked. So during the recovery time, SQL Server can check what was the last log sequence number this page was updated with. And then only it goes and change your data. And as soon as it changes the data, as I said before, now this page is marked as a dirty page. And then when the data is changed, it releases the latch, but it does not release the lock. And then it happens for each page, right? Because I said it's a billion record. So most likely your billion record is not going to fit in one 8K page. So it goes and keep doing the same thing. Once it's done, it will flush the logs to the disk. only the logs. To release the log and say commit transaction. Now, in this process, nowhere I flush the dirty pages to the disk, right? I only said flush the log. So your pages are changed. They're still in the buffer. They haven't been written to the disk. The only thing we did is we flush the transaction logs. And that is what is called write-ahead logging. So at this point, if we have a crash for whatever reason again, SQL Server will read those logs and will change the pages in the disk because this transaction was committed. And if the transaction was not committed, if SQL Server say did half of the stuff, whatever you asked, and crashed, SQL Server will go and unwind those changes for us. There are few other processes within the SQL Server also write pages from memory to the disk. And again, I know those that are not the topic for today's talk, but I'll mention those two very briefly, and then we'll go deep dive into the checkpoint. So the first one is called lazy writer. So the lazy writer's job is to keep enough free space in memory for many things to happen. I'm not going to go there. There's a big list of what are the things that it tracks. So lazy writer can evict clean pages and also dirty pages from memory and write back to the disk if it thinks that we need more space in the SQL Server buffer area. And again, write-ahead logging will always happen for writing the dirty pages to the disk. Doesn't matter if it's by lazy writer or if it is by the checkpoint. There's another process within the SQL Server, and these are all system processes called eager writer. And eager writer is mostly used when you are doing the minimally logged operation, like bulk insert or select into. So what eager writer does is it allows actually creating or creating new pages, new data pages, and it also at the same time flush the pages to the disk. It doesn't wait for the whole operation to finish. Just to it's mainly due to the performance reason. SQL Server have this process, and I'm not going to get deep into this, but just so you know that these two processes also can write dirty pages to the disk. So back to checkpoint. Before I go into details, there's one misconception that I want to make it clear to all of you, those who are attending, because you will see this oftentimes, even if you ask people, they will give you this answer, that checkpoint only write the pages for the transaction that has been committed, but that is not true. It doesn't matter if a transaction has been committed or no, checkpoint will write all dirty pages to the disk. All dirty pages. So even if you're in the middle of a transaction, it modified a page and it hasn't been committed, that page will also get written back to the disk when a checkpoint happens. So what are the things that happen during a checkpoint? SQL Server will create a log record about the checkpoint, that a checkpoint is starting. SQL Server will write that log record to the disk. And when I say we write that log record, means all the log records up to that log sequence number that hasn't been written, everything is going to be flushed to the disk. As I said, always write ahead logging. The logging has to be flushed first before the data pages get flushed into the disk. After that, all dirty data pages, again, all dirty data page, doesn't matter if the transaction has been completed or no, committed or no, they will be written to the disk. Then the LSN of this checkpoint will be recorded in the boot page. And this is very important. When SQL Server restart, it actually goes to the boot page, look at that log sequence number. That is how SQL Server knows from which point it has to start the recovery, from this LSN number. Once that is done, if your database is in simple recovery model, it will mark the VLF, something we call virtual log files. Your transaction log file get chopped into smaller chunk. And again, why does that happen? That itself can be probably a 15-20 minute talk. So it marks those inactive. So SQL Server can reuse those portions of your log file. In case if you're in a full recovery, that doesn't happen till you back up your transaction log. Those VLFs doesn't get marked inactive, so you cannot reuse those if you're in a full recovery. And then checkpoint end, there's another log record get generated, which you'll see that my checkpoint is done. Any questions so far? No. Okay.
No, I think it's good. Yes, you're explaining very good way. Thank you. Please continue.
Thank you very much. Okay. So there have been some improvement in SQL Server 2016 in regards to checkpoint. Actually, a side effect of checkpoint, as I said, if you are updating a bunch of records, for an example, if SQL Server has to write every update to the disk, it's going to take a long time. So there's another reason is SQL Server bundle these IOs, right? All the updates together. All the pages, and then it doesn't go and write a single page. As you can see here, the IO size for a checkpoint is a 1 megabyte. So if you have 8K pages, so you can imagine, I think it's 1024 pages, I believe. Yeah. So it can take all these pages, bundle those together, and just do a single IO, physical IO to the disk. Pre-2016, it was only 256 KB, and this was increased in 2016 to 1 megabyte. Also, checkpoint also throttle itself, right? If it sees that your IO is taking longer, the checkpoints will throttle its right. So pre-2016, this was 20 millisecond, and this has been increased to 50 millisecond in 2016. There's also something called startup options that in SQL Server, there are many other startup parameters that you can use. The one of these is called -K. This is the advanced one, so be careful if you want to use it. This is the instance level setting, so this will impact all your databases, but this doesn't impact your indirect checkpoints, which we'll talk about. So you want to make sure, just be sure to know that why you are using it, right? This also limits the number of this basically limits the number of IO requests per second, and so yeah, just read about this if you really want to use this. So I'm just going to go to a quick demo, and then we'll come back to slides again, and then we'll continue. Okay, so I'm using a SQL Server 2022. It's not in general purpose yet, but the release candidate one is out. If anybody is interested, you can download it from Microsoft website and you can use it. So we're just going to create a empty database, SQL Server 1039, and then create a database. And I'm going to do some setup just to keep the transaction log records scattered to a minimum. I know this is a bad practice, so do not follow this. I'm just doing this for demo purpose. So I'm going to create a table and just insert one record, just one column in type. And now we updated, we did insert a record. I mentioned during my presentation that we can go and see how many pages we have in buffer and if those pages are dirty or clean. As you can see, my table name, schema name, object type, I only have 2 pages in buffer and both are dirty because we haven't written these pages to the disk yet, right? We pulled it from the buffer and we modified the page. Now, if I do a checkpoint and go and run this again, now you see that dirty page is 0, clean page is 2.
Yeah.
Now if we go and try to see the transaction logs, this is how your checkpoint started. Checkpoint end. Transaction is started. We inserted a record and then we commit. Now let's start a explicit transaction with a begin chart, right? And we do insert. And we're not going to commit this. And now if I do a checkpoint, so remember I did not commit this insert statement. So we have insert begin transaction. We did insert. We started a checkpoint. We end a checkpoint. We did not commit this transaction. So this is the LSN number. Take this. Put this there. And now, if we go to this record, I put this in the comment if someone wants to follow this later on. This is the checkpoint one. if you take this log record, you will see that in this log record, somewhere 648, these are reversed, so it's not that simple to read, but you will find somewhere here this LSN number is recorded. So now if we have a power failure or whatever, SQL Server from this record, it will know that I have a transaction that has a begin, but it never committed. It will go and unwind or undo this insert statement because this was never committed. How do we know that? If we do a commit run and checkpoint now, so we do not have anything, right? We do not have a record for that insert statement because it has already been committed. We just have a record for checkpoint start and checkpoint ended. Yeah, so for cleanup, you can just drop that database. So hopefully it made some sense of what I'm talking about. There are 4 different checkpoints, as you can see. The indirect checkpoint was first introduced in SQL Server 2012, and it became default in 2016. I just want to caution you, when I say default in 2016, what does that mean? If you are creating a brand new database in SQL Server 2016, indirect checkpoint will be turned on automatically. If you are restoring your old database from an older version into 2016 or above, indirect checkpoint will not be enabled automatically because when you restore, it brings the settings from the previous server, right? Wherever you get the backup from. So even after you restore, if you want this database to have indirect checkpoint, you will need to go and configure that manually. So just keep that in mind. Okay, so the first one is automatic recovery, and this setting, this is controlled by a setting called recovery interval, and the default is 0. So if you go and in a server, look at the recovery interval, by default, you'll see it is 0. So what does that mean when I say like recovery interval, the default value is 0? What is this telling us, right? What does that mean for us? So by default, SQL Server will try to keep your recovery time in less than a minute. That's SQL Server tries, right? It doesn't guarantee you that. But the problem is that estimation of keeping it under a minute is based on the number of log records. So SQL Server has a standard time for each for each log record. It estimates that I might need this many milliseconds to recover, right? Yeah, and that's how it tries to keep it under a minute. But the problem is that SQL Server doesn't take into consideration how many dirty pages I have per log record, right? Because I can have a small operation and this log record might just have 1 dirty page, and I can have a huge update or insert or delete, and that can also, that can have thousands of dirty pages, right? But SQL Server doesn't look at that. It's just based on number of log records. That's the one problem. The other problem is the long-running transactions. Right? If you have a long-running transaction, I'm sure if you have been working in the database world for a while, We all went through this, right? SQL Server crashed, SQL Server rebooted, and now it is undoing all those operations, right? And you're sitting there, your boss is sitting there, everybody's walking around you, they're always keep asking you. And the worst thing that people do is they reboot their server, then it starts from ground zero again. So never do that. I know there's something called accelerated database recovery, and you should definitely look at that if it does fit your, your workload or your RPO, RTO. You should use that. But coming back to our topic, uh, so this setting is really not reliable, right? There is no way to guarantee that you recover within 1 minute. And even if you read Microsoft documentation, today, if you read that, right, Microsoft clearly says that the recovery interval setting is unreliable. It cannot determine an accurate recovery duration. You will see it even written in the Microsoft's documentation. So when do you change default? And should you change it, right? So I would caution you before you want to change it. Make sure you understand what you are doing. Do not just use a bigger number, because you can set it to a large number, but understand the consequence, right? So if your recovery is taking significantly longer than 1 minute, and when you do not have a long running transactions that is being rolled back, then you should look at it. If you see that your frequent checkpoints are impairing your disk IO performance and it's impacting your workload and eventually your customers, maybe you should look at that. But whatever you do, do it very gradually, right? And you can use SP configure. And if you are using a value less than 60, you do not need to use override. If you are using more than 60, then you need to use the override statement. And you can read in books online, what override does. The other one is a manual checkpoint. So I can go and issue a manual checkpoint anytime with a small piece of T-SQL. You just say checkpoint and it will does it for you. You can also pass a parameter with that that is called checkpoint duration, and the value is in seconds, though the engine doesn't guarantee that it will respect that duration, but it will try to complete within that duration that you put in. So when do you use manual checkpoint, right?
Hello, hello. I just interrupt 1 second.
Yes.
Could you go back to the last page, last slide? Just back to the last slide. Just previous one. No, next. Next.
What is your
Next.
no? What is your question?
Uh, you, you are talking about the automatic setting. I just go to that page. The log sequence, the choice is automatic. That is describing you the less than the 1 minute.
No, what is your question?
Yes, this here. This is the automatic setting, right, from the 2012 or later. Okay. So this is the by default. If the setting is automatic, then the default. What is the default time? Is it 60 seconds or something? I am not clear. If the
The
setting is
default
automatic, so what is the time? Default time.
the default is set to 0, and the 0 means the database will typically try to recover in less than a minute. But again, as I said, this setting is not reliable because of the reasons that I explained.
Okay. Thank you.
You're welcome. Okay, when do we use a manual checkpoint, right? And most likely, there will be very few occurrences that you use manual checkpoint, especially after 2016. Pre-2016, a lot of people, if they had an issue with the IO burst and their workload was getting impacted, people will use manual checkpoint to smooth the IO that we'll see in the demo. And I even have experienced that people will set up SQL Server agent jobs that will do manual checkpoints at a very frequent interval. So I wanted to Twitter use the SQL help hashtag to ask the community, like, do they use manual checkpoint, and do they also use the parameter that's checkpoint duration? And I don't know, if you follow Aaron Bartran, who used to work for SQL Sentry, a long time MVP, and he does a lot of blogging. So there are a couple of answers that I got, and I just put three here. That when do people use manual checkpoint? The one thing was very common, that none of them use the checkpoint duration in their in their experience. So I'm not going to read all these tweets, but I'll let you read it when you download the slide. SQL Server also does internal checkpoints, right? So whenever we do a backup, whenever we do a dbcc check db, we start a stop SQL Server engine, or we add remove database files. So there are, it's listed in the in Microsoft documentation, even though we don't see it, but behind the scenes SQL Server will issue a checkpoint during some of these operations. Now, indirect checkpoint was introduced in SQL Server 2012. The good thing is indirect checkpoint does not use the number of log records. Indirect checkpoint will use the number of dirty pages, which is more accurate or more practical than using number of log records. So it keeps tracks of number of dirty pages, and this setting is done by something called target recovery time. And again, by default is 60 seconds. So today, if you go in 2016 and above, you create a brand new database, it will have an indirect checkpoint time of 60 seconds. And this is per database. Even if you have a backup restore, or if you have a reboot of the server, this value persists. And if you take the database that has been created in 2016 or above, you take it and restore in a different server, this value will persist because this is a database level setting. As I mentioned before, indirect checkpoint SQL Server 2016 is the default behavior. It's also in the model and TempDB. And this indirect checkpoint caused the issue in 2019 with the non-yielding scheduler errors. And that was fixed in one of the CUs. I believe it was CU 5 or 8. I'm not sure yet. I'm in 2019 right now. I think CUs are running in the number of 20s, right? So yeah, it was fixed a lot earlier. If you want to disable the checkpoint on TempDB, which I'm not recommending, if you have any reason to do that, there is a trace flag 3468. 3468, if you can add that to your startup parameter, and that will disable indirect checkpoint for your TempDB. Not that I'm suggesting, but in case if you have an edge case that you want to do that, there is a way to do it. This is a complex slide. I'm not going to read everything, but if you go to the URL that I put at the bottom of this slide, this URL will take you to a blog post by Microsoft engineers that will explain, indirect checkpoint, and all the details about how does it work. So basically, per database actually create a bunch of lists to be accurate, exactly 128. It keeps tracks of all the ready pages, and then when there is a checkpoint, it goes to that list and find out all the list of the ready pages. It bundle all of them together. There's those who are neighbors, and make a together all these pages, right, in one go with a big size of IO, right? And that's how it minimizes the physical IO to the disk, and it's also very efficient. Uh, if you have a very high transaction databases, then you get into some issues, and it also explains how Microsoft fixed those in SQL Server 2019 CU, whatever number is that. So if anyone is interested, go to that URL, and you can read more details on this. Now, how do you monitor checkpoint, right? Most of the time, we probably wouldn't want to monitor checkpoint, right? It's automatically happening behind the scene. I don't need to worry about. But oftentimes, you might see IO spike. And how do you rule out, or how do you guarantee that this spike is not due to a checkpoint, or is due to, is it for checkpoint or not checkpoint? Right? How do you rule that out, right? If you have an IO issue, the only way to do it is by monitoring checkpoint, and then you can be sure that okay, this is not due to this, it's probably something else. And if it's for checkpoint, then you can probably look at your interval for your indirect checkpoint and do other stuff, and also want to make sure why so much transaction log is getting generated, why maybe you need to write your query more efficiently, but that's a different discussion. So there are a couple of ways you can do that. The first one is a WMI counter, checkpoint pages per second. One disadvantage of that is it tracks the pages for all databases together. So you really wouldn't know which database, if you have multiple ones, if you just have a single database, then, it's good for you, you're lucky. But if you have multiple ones, then you really wouldn't be able to track it, with this. So there are two extended events, checkpoint begin, checkpoint end. So you can set up extended event trace, and then from that time you can correlate with your IO spike. You can also use some trace flags, which we'll do. I mentioned this here. I'm not going to read this. So you can use this to trace flags, turn it on, and then your checkpoint information will get logged into your SQL Server error log, and you can query it from there. If you can mute, if you're not talking, that'll be nice. So then checkpoint TempDB. I'm not going to read detail about it, but I'll just mention you briefly. Because TempDB is always in simple recovery model, TempDB will only have an issue a checkpoint when your log file is 70% full. It doesn't care how many dirty pages, it doesn't care how many transaction log got generated and all that. It only, when your log file is 70%, it will issue a checkpoint. It doesn't have any automatic checkpoints. You can still do manual checkpoint, yes. And the VLFs get to inactive like any other simple recovery databases, right? So as soon as your logs get full 70%, checkpoint issued, VLFs will get marked to be reused. Okay, so it's time for another demo, and then any question. This will be a good time to take questions if anyone has any.
It's okay, Taiob bhai. Everything is clear. Thank you.
It's okay.
Okay,
It's okay.
thanks. Okay, so I'm planning to show three different things with this. How do you monitor a checkpoint behavior for simple recovery database, and a difference of automatic versus indirect checkpoint, right? how can we smooth your IO by turning on indirect checkpoints or playing with some of the thresholds of indirect checkpoint, right? So in this case, I already created the database. I've done this. I can do that again just to make sure. I'm using a different database. I mean, same name with the demo2. And I'm going to create an empty table. This has few more columns than what we saw before. I'm going to create some store prog that I'm going to use for demo purpose. I use a logic, from this URL, just so you know. I took some help from there. I want to mention that. So now I'm going to run a performance counter. I'm also going to run these two store procedures that I created with SQL query stress. If you do not know this tool, look it up. You can quickly, do some stress tests, check your store procedures if you're making any change, pre and post. This is an awesome tool to use. This was initially written by a gentleman named Adam Mechanic, who wrote SP Who is Active, which many of us use around the world. And now he put it in GitHub, so it's open source. You can also contribute. So as you can see here, I have this tool and I'm pointing to my SQL Server 2022 that's sitting in my laptop. I said, use 20 thread, iterate for 100,000 times, right? So I'm going to get this going. So these are running behind the scene against my database here. Now, let's monitor this. So I'm going to turn on, make sure I have this turned off first. Okay. So I'm going to turn on this two trace flag, recycle my error log so it's easy to read. Okay. So now you see that checkpoint begin and checkpoint completed, right? So this is being written into your SQL Server error log. And if you see IO spike and it matches with this timestamp, then you know that this is due to the database ID 11. Of course, you can look up your database name. But this doesn't really tell me how many pages are being flashed and anything, right? So if you want a little bit more information, you can also turn on another trace flag, 3504. Here we did 3502. And 3605 is a generic one. If you want to redirect your output to your error log, you need this 3605. So let's recycle the error log one more time so it's just easy for us to read. Now you see, because we turned on the other trace flag, you get a little bit more information, right? Give you how many megabytes per second, your throughput, how many pages and all that. So this is one way. As I said, you can also do extended event trace. Do that. Now, I also have a part mode counter. Oh, no, sorry, wrong page. So look at that. I have 3 counters, right? One is a percent log used, which is this one. As you can see, it comes to 70%, about 70, does a checkpoint because this database is in simple recovery. Again, climbs up, does a checkpoint, climbs up, does checkpoint. If it doesn't make sense, please stop me because I don't want to go too fast and then you're not following me. And the red line is your disk write. And you can see some IO burst, right? Right here, the peaks. Now, if this, right now there's one happening, right? Now, if this peaks is a problem for you, for your workload, what you can do, I can say I'm going to set my indirect checkpoint to 15 seconds. And let's go and see what happens. So from here, see how frequently now the checkpoint is happening? It's not waiting for the 70%, right?
Yes.
And you don't see these peaks anymore for your IO spike. It's a lot more flattened. So if these spikes are an issue for you, you can do this. And I put another piece of code if someone is interested. If you have time, I want to wrap up. You can also go to the other extreme, go to 120 seconds and see how it works, right? So I put that code there in case if you're interested, you can run that and look at the performance counters. And I have all this detail here. What are the performance counters I'm using? You can add few more. To see some more metrics. So let's wrap this up. So the next speaker can get ready. I did put a bunch of references. If you want to read more, understand more, and this is an interesting topic, and we should all have some basic knowledge about this. Again, these are my contacts, and really thank you so much. Thanks to the organizers to put this together. And all the speakers, volunteers, and I think I'll finish it here. I kind of lost track of time. I think we started a little bit after the hour, so I don't know if there's any time or if anyone has question, I'll be happy to answer those. But if we are in a rush for the next speaker to get going, I'm absolutely fine, keeping my mouth shut and listen to the next speaker.
So I don't have a question, but I have a comment. So I really want to thank you for the session. This was very informative. In the last 3 or 4 years, we've seen less and less sessions about SQL Server internals, about optimization, and we actually need that because the kind of sessions that we are seeing now are more general towards AI, etc. But these kind of things are still everyday life, and we actually need them. So thank you very much.
Oh, thank you. I submitted one in SQL Bits about myths about backup because recently I talked with 100 people. I found out people still think that full backup breaks the blockchain, which is a surprising thing. I think because of people think all the nothing wrong. I use Azure a lot. People think Azure AI and ML is going to take over the world, but I still think if we do not know the basics, we're going to struggle in every step. So I'm a firm believer of that.
Exactly. Thank you very much.
You're welcome. You're welcome.
Yeah, it was a very fruitful session. Actually, you described many important issue. Please, if you share your email or contact address, it will be helpful for the next time because the time is very short. We will ask you in detail some question because I have some personal question, but time will not be covered. So,
so
could you
you
share
can,
your contact address? Could you share your contact address?
yes, you can take all this. You can
Yeah.
contact me in any of this. I monitor all four.
Okay.
So
Okay.
yes,
Okay. Thank you. Thank you.
you're welcome.
Ex-
Okay, I'll stop
Excellent.
sharing. I think Dipti is coming next. So
Thank you
We
very
are
much.
immensely
Taiob
pleased.
bhai.
Bhai, thank you so much.
you're welcome. You're welcome.
Hello, Taiob. Good morning.
Good morning, Dipti.
How are you?
I'm doing great. Getting ready for tomorrow.
Me
I'm
too.
flying at 11 o'clock. Excited. So yeah,
Tomorrow, me too. I'm flying at the same time, 11 a.m.
awesome. Okay, so I'm done. I'm going to go on mute and let the next speaker get settled. Thank you again.
Thank you.